Okay, so here are the last problems in section 3, chapter 3. So we have problems 79, 82, 85. Actually, I think I had 79 done, so we'll do 82. So these are use truth tables to decide which of the pair of statements are equivalent. So we're just looking for equivalence, so that means that we as long as do a truth table and end up with the same truth values at the end, in good shape. So 82 has the negation of if P then Q, and the second statement is P or P and not Q. Okay, so we need 2 for P and Q, and 1, 2, 3, 4. This is a 6 columns, and we need 5 rows. Okay, so that's the first one. We'll just put that there. And this one we just need 5 by 5. Right down there. Okay, so the negation of if P then Q. So write P, Q, the negation of the if then statement. The whole idea here is that, we're trying to replace the if then statement using ands or ors and negations. Just because in circuits it's easier to do the ands. Okay, so these first 2 columns are just our usual pattern that we use. So we just copy, in this case, it's just copy the column P and Q columns. Then we do what's in the parentheses first. This is the if-then statement. The only time an if-then statement is false is when the first one is true and the second one is false. And then we take the negation of this whole thing, parentheses, which is the negation of this column. So we get false, true, false, false. So that's what we're going to compare here in a second. Okay, then we do, again, the first 2 columns are just the pattern. Same pattern we had up here. We write down P, write down the negation of Q, so we switch those around. And then we have the and statement. The only time the and statement is true is if they're both true. All the other ones are false. So that's the end, that's the result of this one. You can see we have false, true, false, 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 true, false, false. And then therefore we can say that equivalent, not equivalent, let's do equilibrium, but these are equivalent. And the book says equivalent, so that's good. Okay, the next one is 85. So the question is, are these 2? So we have P and the negation of Q. Our second statement is the negation of Q. If the negation of Q, the negation of P. Again, this one's going to, these actually both have the same size. They have 5 rows and 5 columns because I don't have a negation of the whole thing. So there's one less thing I have to worry about. So we'll do the left-hand one first. P or and not Q. Okay. So P, Q, P, and not Q. True, true, false, false, true, false, true, false. Okay, so we just, in our logic expression, we just have P here, so we just do our P pattern. And then for the negation of Q, we do the opposite. So we have false, true, false, true. The only time that an and statement is true is if they're both true. Otherwise, they're all false. We actually end up with the same pattern over here, which makes sense because that's the same statement. Okay, then the second one, the conditional statement, negation of Q. If the negation of Q, then the negation of P. So again, the first two columns are just filling them out in the pattern that we are to do it according to. Negation of Q, we take the Q column, we just switch falses to trues and trues to falses. And likewise, negation of P, we change the trues to falses and falses to trues. And the final one is this operation, if-then statement. The only time an if-then statement is false is when the first one is true and the second one is false. That's the one that's false. All the rest of them are true. You see that they're actually the opposite: false, true, false, false. This is true, false, true, true. So if I had done the negation of Q, if Q, then negation of P, that one would have worked out right. But the one we were doing was not that. It was just if the negation of Q, then the negation of P. So comparing this column with this column, they're not the same. And so we can say these are not equivalent. Okay, now we go to the circuits. So circuit 91 is this. So these are parallel circuits. This is P, this is Q, this is P, this is the negation of Q. So this is equivalent to an OR statement. This is one part of the first part of the OR, this is the second part of the OR. So our logic expression is going to be P. Now these are in series. These two are in series. P and Q here are in series. So series means and. Likewise, these two are in series. So it's P and the negation of Q. But these two are in parallel, so we put an OR statement for that. And this one says the statement simplifies to P in the answers. Why is that? Well, if we did the truth table for it, what we'll probably end up is that we get true, true, false, false. So let's do this. So we get P and Q, 1, 2, 3, 4, 5, 6, 7. So we get 4 and 7. I mean 2 and 7, which is 9. So we'll do one that's, for me, I'm going to make it. Let me undo that for a second. Okay. Okay, so there's my table. We have P. It doesn't ask us to do this, but since they mentioned it in the answer, I just want to go ahead and show you how this works. So these are our true, false, true, true, false, false, and our pattern that gives us all the combinations of trues and falses. Okay, P column is just true, true, false, false. The Q column is the alternating true, false. P again is true, true, false, false, and the negation of Q is false, true, false, true. Okay. Now we do these operations. So the only time a AND statement is true is when they're both true. So the first one's true because we have two trues. Here, the second one is true. All the other ones are false. And then we have the OR statement, and we're comparing these two columns right there. So for a OR statement to be true, just one of them has to be true, or the only time an OR statement is false is if they're both false. So notice these two are false, so this one's false. These two are false, so this is false. The other ones have at least one true, so you get true, true. And notice that this is equivalent, is the same as that. So just P by itself is the same as going through this whole, we could replace this whole thing with just P. So that's what they're saying. And then we have 94. So here we have Q. Next we have, on the lower end, we have P. And we go to this parallel one. So we have that, which is Q. This one's Q, this one's P. This one is Q, this one is the negation of P. Negation of P. This goes over here, connects there, goes back up, goes like that, comes out. Okay, that should match up with what's in there. So the way we do this is this part, they're in parallel. So that means we use the OR statement. So we'll have Q or not P. Then we have this in series with this thing. So these are both end to end. So this is going to be connected by an AND statement. And then that whole thing we're going to put in brackets to represent the bottom part. And then we have OR Q. So Q is the top leg. This bottom part is the bottom leg. And according to, it says the statement simplifies to Q. So yeah, it does say simplify the circuit. So actually we didn't talk about that in class. So we need two columns for P and Q. And we need 1, 2, 3, 4, 5, 6, 7. 7 and 2 is 9. So same size as the last one. So we take this one, squish it up, clone it, and we overlap one of the columns. Okay, so to evaluate this, we have P, Q, first column. Then we have Q, or P, and Q, or not P. Okay, first two columns, same thing. True, true, false, false. True, false, true, false. Okay, always the same for two statements. Then we fill in all the columns that are either just P, Q, or negation of P, negation of Q. So Q, P is true, true, false, false. Q is true, false, true, false. Negation of P is false, false, true, true. Then we go to the end of parentheses. That's a OR statement. It's this part right here. So the OR is false only if they're both false. So this is the only one that's false. So the other ones are true. Okay, then we do compare this one with this. So the result of the parentheses is this column. This is the other. This is an AND statement. So the only time an AND is true is if they're both true. So we only have one case where it's true. We have true, true. We have true, false, false, true, false, true. So we get that. And then finally, we compare these two columns. Because what this is, this column represents this whole thing. And this is an OR statement. So the only time the OR statement is false is if they're both false. So we have true, 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 false. Okay, so the only last one is two false. Everything has at least one true in it, so they're all true. So that's the result. And as you can see, that it's the same Something's wrong. Oh, I didn't do good comparison here. Okay, so true is true. False is false. This is false. This is true. True, false is true. False, false. So they're both false, then they're false. So it's the second and fourth one. And now if you compare these two, you'll see it's true, false, true, false, true, false, true, false. So because these are equivalent truth tables, you can replace this whole thing just by Q.